All right, guys. So the infamous video for the project. Okay, here we go. So we were thinking about this earlier today of how much we actually wanted to give you as far as information because we didn't want to do the project for you. That would defeat the purpose of you gaining all that knowledge and that experience of knowing how to calculate this real world problem that is very, very powerful in the real world application of when will I ever use this information in life. So Unit 7 is huge right now as far as the real world applications that you guys can learn from this unit and how in your real life in the future you will use a lot of this information um, in many beneficial ways. Okay, from buying a house, cars, so on and so forth, whatever it is, it's a real good place to start as far as being able to predict future models. And that's the premise of this project. Okay, so the project, let's go to read through it together. In case you haven't noticed, the town of Prosper has undergone some pretty intense growth spurts recently. Parents, students, and other community members are all concerned about what about where we are going to put all of our students. Can we build schools fast enough to accommodate our proliferation? How many schools should be built? So on and so forth. Fortunately, we are in good hands. Prosper Independent School District has hired you to sort through the entire mess. Okay, so the recent population trends and make educated predictions about how many new elementaries, how many new middle schools, and how many new high schools will we need. So your mission, okay, for this performance task, your mission is to study the PISD population chart on the next page, and I'll go to that here in just a bit. Use your knowledge of functions and regressions to find the functions of best fit. So the line of best fit. We've done that with linear regressions. We've done that with quadratic regressions. I'm going to include in this video some examples of how you can use quadratic, linear, or even exponential regressions with a calculator. I've also here in the calendar attached links of Desmos and also Nspires of how to do this as well. Okay, but I just wanted to kind of put it all in one video, and then you guys could go back and watch the other ones if you needed to, if you were still lost a little bit with the calculator. Again, these videos, pause, rewind, listen to it again. That's why we are recording them as videos, so that we all get that same instruction and pretty much we're all on the same page. All right, so your mission is to study the PISD population chart on the next page, use your knowledge of functions, find the line of best fit. In this case, it could be regression, it could be a quadratic, exponential or quadratic. And then we're going to create scatter plots of the data along with your functions of best fit. Use your functions of best fit to predict how many students will we have and how many schools will we need 5 years from now. So in the year 2024 and 2025, that's 5 years from now. Okay, since we started this year 2019 to 2024, that's 5 years. We're ending it in 2020 to 2025, that's also 5 years. So however you want to look at it, there's your 5-year span. Then estimate how many students we will need or have and how many schools we will need in 20 years from now. So 20 years from 2019 goes all the way to 2039. And then 2020 is when we're going to end this school year. It goes all the way to 2040 for 20 years. Prepare a professional quality presentation. You will use Google Slides. I will repeat that. You will use Google Slides and make it very professional quality. And we're going to have a post on our Google Classrooms where you'll submit and turn this in of your findings that you would present to the school board. Okay, so these are our due dates, current due dates as of now. They are fluid. They could change possibly, but please, unless you receive word that they will change, kind of think that these will be our due dates going forward. Okay, so the project is worth half a test grade, and here's the grading rubric. So you will get 12 points max on the scatter plots, 12 points max on the functions, 11 points on the 5-year prediction, and then 11 points on the 20-year prediction. So there's 22, 30, 42, 43, 44, 45, 46, and I believe the other 4 points are coming from right here, the professional quality, which will get you to that total of 50 points. Okay, so this is out of 50 points total. So again, these last 4 points come from your professional quality. All right, so we want the scatter plots titled, labeled, completed, accurate, and neat. We want the functions of best fit written down, they're drawn, they're accurate and neat. The 5-year predictions, did you predict the population? Were you accurate with the number of schools? Did you justify your predictions? And then population prediction for 20 years, were you accurate with those number of schools? And did you justify? Did you give enough evidence and proof of why your predictions were correct? And then again, last but not least, professional quality. Make sure that it is professional. Please take care in ensuring that. So it says right here, study the PISD population chart, okay? So that is right here. If you click on this population chart here below, it will pop up this population chart that you see here. And you see PISD, these are actual numbers that we got from the district in 2007 to 2008. Kindergarten all the way to 5th grade. This right here is considered down here your elementary level. Okay, so kindergarten to 5th is your elementary. 6th through 8th are going to be your middle school, and that's back over here, middle schools here and here. And then our high schools are this last sectioned off section from 9th grade to 12th grade. Okay, so in 2007 to 2018 2007 to 2008 school year, 214, 194, 194, that's how many students we had in middle school. Okay, and you can see the middle schools are growing to 2019 to 2020. We have 1,462 6th graders, 1,346 7th graders, and 1,219 8th graders. So we've definitely grown all in all, K through 12, from 2,572 all the way to 15,978. We are definitely growing. Okay, so those are the numbers that you're going to use as far as to predict your model. Okay, so I did record other videos that show the linear, exponential, and quadratic regressions, but I wanted to quickly just show you how you could use that one more time on this video with the calculator. Okay, so real quick, I'll just come over here, press 1 for a new document, note unsaved changes. Let's get a calculator page. And I'm going to go ahead and press Control, add a page. And like I did in the other video, I'm going to add a spreadsheet. I'm going to use those same points that I used in the other video, 83, 71, 64. And let's use 69 and 69. And then over here we have 183, 168, 171, 178, and 176. These were my input X values. Now again, these numbers have nothing to do at all with the populations that you saw over here on this population chart. Okay, but I don't want to use these numbers because then I'm doing it for you. And we don't want to do this for you. We want you to use the knowledge that you're learning from this unit and the knowledge of how to use the calculator to come up with those models yourselves. What numbers should be what in the equations that you're using, so on and so forth. All right. So from here, there's a couple things that we can do to calculate the graphs. Okay, so real quick, I can control add a page, and I can add a 5, press number 5 for that data and statistics, making this my x-axis, making this my y-axis, and I can from here calculate by doing analyze regression, and I could do linear regression, mx plus b. That would be the line of best fit. Pretty much the line that goes through all of this data as clean as possible through the center, if you will. Okay. If I didn't think that that was good enough and it had way too much error off and it wasn't an accurate or a close prediction of this model, I could have tried another regression. I could have tried something like quadratic. Maybe it's quadratic. And there's my quadratic equation, ax squared plus bx plus c. Okay. Or I could have even done analyze regression. We're in exponentials right now and logarithmic. Here's an exponential model. Y equals a times b to the power of x. Okay? And if you want more decimal numbers, you could press menu, settings, and change this float to just normal float. Make it your default, and it will show you more decimals. If you don't want that many, you could change the float where it was just a couple of them. Settings, change the float to, let's say, 3, and it would show you those right there. There's 3 decimal places right there, or 3 significant digits, that is. However you want to do that so that it shows you enough data points, and typically a good rule of thumb is to do like 3 decimal numbers, like 3 numbers after the decimal point. So in this case, it's like 1.003. That's more accurate than, that's the best accuracy that you want. That's like for AP calculus here at the end of your journey in math, those 3 decimal places are what we're looking for. Now, going back to my scatter plot, from here, if you want to see which one is better, you want to find something called the correlation coefficient, okay? And that's just the R value, okay? So correlation coefficient shows the strength of which one is best. And we want the strength to be either as close as it can to be to 1, the number 1, or as close as you can to be to the number -1. So anything in between -1 and 1, the closer and closer it gets to 0, it's going to be weaker. But the closer and closer it goes outward, getting closer to 1 or getting closer to -1, it's going to be stronger, saying that's the answer. That's more the answer because it has a stronger correlation coefficient. So let me show you how to find that. From here, and we would specifically, okay, we're going to specifically choose the first row, third column, right after our data points. We would press Menu, Statistics, Stat Calculations, and let's say we thought this was a linear line, okay? I will press X and Y for my input and output, and then just press OK. And right here, it's telling you, this is your equation, right here. Y equals mx plus b, where m could be 0.577 if you round up, or 0.576 that you would put right here, and b would be 134.139. So 0.576x plus 134.139. That would be your best, or your line equation. Okay, that's what you would put as far as the equation for that line that we saw over here, right here, if it was linear, that is. Okay, and you see it right there. It already calculated that stuff for you. Okay, and it rounded up, as you could see. The R value is what we're looking for. If this is R squared, then we're wanting to take the square root of this number. All of this, we're trying to take the square root of it so that we can find out what is its R value. So I can come over here, take the square root of that I just saved. Let me see if I can paste that, and then see what we get. There's our R value, where it's kind of strong. It's at 0.7. The closer it gets to 1, the stronger it is. But it's kind of far from 0. It's not close to 0. It's actually closer to the number 1. If you kind of look at 0 and 1, 0.5 is in the middle. This one's closer to 1. So it's fairly strong. Okay? So let's come over here and let's test it. Going back to our data points, C column, first row, we're going to go from here. We're going to press Menu, Table. Whoops. Let me do something real quick. Okay, right here. So again, this is the third column, first row. We're going to do Menu, Statistics. We're going to do Stat Calculations. And this time, what if it's a regression that is quadratic? So let's do the quadratic. Let's put X for our input, Y for our output. Press OK. It will overwrite the data that you had from that line. And now there's your equation. This is your standard quadratic equation that we have learned in units past. 8x squared plus bx plus c, where a would be 0.026, b would be negative 3.330, and c could be 277.983 if you're rounding up. That would be your equation. So if you want to see how strong is this a better model than the last one? Well, look at your R squared value. If all of this right here is R squared, then if I took the square root of it, it would give me my R correlation coefficient. So let's go ahead and do that. Let's take the square root of that R squared value so that we get R. And you see this one's stronger. It's closer to 1. So right now, instead of a line, a quadratic is actually stronger And this picture shows more of a quadratic than just a line, okay? So let's finally go and check, and we can check several of them. You know, you don't just check a couple. You can check the exponential, the quadratic, and the linear, and even more. There's other functions. Let's press Menu, Statistics, Stat Calculations. It could be cubic, like x cubed. It could be quartic, x to the fourth. You know what I mean? So it just depends on, we have to calculate the correlation coefficient and see which one's stronger. Well, we're in exponential regression right now, or sorry, we're in exponential and logarithmic unit. X and Y are my input and output. Maybe this one's stronger. Let's see. It overwrote that quadratic that was up there before. And here's my equation. A times B to the power of X, where A would be 138.966 times 1.003 raised to the X power. This is my R squared value, and this is my R value. It already has this for us. On some of these, it will have it already there for you. If it doesn't, we're going to do like we did on the other two. We would just copy that down, write it down however you want to do it, and take the square root of that value to see what is the strength of that exponential regression in this case. Well, it went even weaker. This exponential was actually weaker than what my linear was. So this is a quadratic as far as comparison to the others. And this is that justification and evidence that we're saying that you're showing way down here on the rubric as far as justify your predictions. You're showing the strength of that correlation coefficient of these numbers that you saw in your calculator to say, well, guys, it's going to be quadratic. This one is stronger quadratic, so it looks like we're growing at a quadratic rate, okay? So then you would use that equation for quadratic, and you would be able to use it to predict future years and whatnot. For instance, I could come back here and I could say, let's go ahead and use that quadratic. Analyze, regression. Let's use the quadratic that we're, actually it's already there. Let's hide the linear one. So this quadratic is here. There's your equation right here. This will predict to where if I wanted to know what it would be in 20 years, I'd put, you know, maybe 20 for X. If I wanted to know in 100 years, I'd put 100 for X. That way I could see what would it be here after so many years. You know what I mean? So that's what we're looking at as far as how do we find those values and or proof and evidence of which one will work best. Now, I did put in this data all these points. And what I can do is I can use this home screen to get those equations as well. So like if you didn't want to use from way over here to get this quadratic equation, if you didn't want to do it from here, again, I'll do it again, to where we had those values of, or we had the statistics, stat calculations, quadratic, you know, the X, the Y, and then to see that equation pop up here, like if it's a little bit messy for you and you don't see the 0.026x squared, like the way you could see it here as well, you can actually do it from your home screen. This will be the last of the video. You can come over here and go to statistics. You can do stat calculations, and you can do a quadratic regression where this is X and Y, still X and Y. And here it can give you the, let me show that one more time. It can give you your, basically your results right here on this screen. Okay, so let me actually do it like this. Stat results. So here, the stat results, this is an exponential model as far as showing you what it would be if it was an exponential model, okay? I don't like to necessarily do that because it went straight to the exponential and it didn't necessarily prove that it was exponential. I mean, it could have been quadratic, but over here, if I did that one more time, from the home screen, that's menu, statistics, we can do stat results. And again, it shows you that exponential, okay? And we just proved with the correlation coefficient that it's actually going to be quadratic as far as the best line of fit. So I wouldn't recommend using that. I would recommend using either this method, or even that other video link that I included with Desmos as far as showing you how to use that justification and find like the line of best fit or the graph of best fit, if you will. But again, If you want to, you can go ahead and do stat results here. I believe you can still do quadratic regression and linear regressions from here. It would be X, it would be Y, and there's a linear regression. Yeah, so you could do a linear regression or you can do quadratic. This looks like it's a little bit cleaner to see rather than that other screen where it's all like in the table and whatnot. And if that's easier for you to see, by all means, please do so. Please use this. But there's your quadratic regression. And sure enough, we got 0.026 x squared, which is the same here, 0.026 x squared, which is the same here. 3 different places on the graphing calculator that you're able to use it. And now you have all the tools you need. Okay, I've gone through the project. You know what's expected. It is again on Google Slides that will be posted on Google Classroom. You have this attached, and it is right there as far as the population chart. So you should be good to go, guys. I would say get a good head start on this because the due date will be here before you know it. And again, those due dates are right here. And they are fluid, they could change, but please make sure that you do begin on this as soon as you can so that you get it all knocked out and that you have an awesome, awesome presentation for us ready to go. Hope this helped a lot, and we will talk to you later.